Okay, we're in chapter 8 now, section 1. This is the first assignment. We're going to be talking about basic integration rules. And a lot of this is going to be review, but we're going to put a little bit of a twist on it. Okay, so let's take a look at this then. This is what I call a tale of three integrals. And it's by C. Dickens, but not Charles. All right, so we're going to have three different integrals. Let's take a look at these puppies. I've got the integral of 3 dx over x squared plus 16. So here's integral 1, integral 2, the integral of 3x dx over x squared plus 16. And integral 3 is the integral of 3x squared dx over x squared plus 16. If you look at these look very similar. They look very, very similar, but they behave very differently. And the only difference, if you notice, is in the power of x we have in the numerator. And this is where a lot of your work is going to lie, is in looking at the numerator. Okay, so let's take a look at the very first one then. So we want to find the integral of 3 dx over x squared plus 16. Well, the first and most obvious thing to try is u sub. Right? Well, so that's great. So we want to do u is x squared plus 16. du equals 2x, and we don't have that up there. So you say, we can't do it. We're going to go on to the next one. And please do that, because I guarantee you I'd love to count it wrong. What's happening with this one is, if you look down at the denominator, we've got a sum of squares. This is an inverse tangent. Anytime you get a sum of squares or a difference of squares or some kind of a square rooty thing with squares inside of it, look at your inverse trig functions. So what I'm going to do here is, well, this is wrong. But what I know is that du over a squared plus u squared is equal to 1 over a times the arctangent of u over a. Okay, well, here's my a. A squared is 16, so a is 4. Here's my u squared is x squared. That makes my u x, and we got it. Because du now is dx. So what do I do now? You say, no. We still can't do it because we got the 3 in front of it. Wrong. You don't. So it's going to be 3 times. So I know I've got 1 over a. My a is 4. So it's going to be 3 over 4. And then I'm going to have the arctan of u, which is x, over 4. And at this point, you'd be tempted to stop. You say, we got this, no problem. Notice there are no bounds here. It's indefinite. So, first integration commandment. You're going to have another one a little later on. So the first integration commandment is the following. Thou shalt use constants of integration for indefinite integrals. If you don't, you end up going to math hell. Okay, so there's the answer to number 1. Well, that's kind of slick. You say, oh yeah, we've had some of these in the past, we haven't gotten them. You're right, you haven't. So there's number 1. Now let's take a look at number 2. So the first thing I'm going to do, or you should too, is whoop that 3 out of there. So I've got an x dx over x squared plus 16. So now you're going to come in and say, yeah, hallelujah. So now we know to use inverse trig functions for all of these things, and blah, 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 but you got an x up here and you're screwed, so we can't do this one. Absolutely wrong. This is a u sub. I'm going to put u as x squared plus 16. du is 2x dx. I've got an x. So now, what I'm going to end up living with is, when I do this, I'll have a 3/2, because I don't have this 2 in there, times the integral of du over u, which is 3/2 natural log of the absolute value of u plus c. Thou shalt use constants of integration. Then we substitute back in. We got 3/2 natural log of the absolute value of x squared plus 16 plus c. And for all real values of x, this is positive, so we can get rid of our natural of the absolute value. So I end up with 3/2 times the natural log of x squared plus 16 plus c. And this is good for all real values of x. Okay, so there's number 2. Let's go in and take a look at number 3 then. We got the integral, or 3 times the integral of x squared over x squared plus 16. Okay, so we're tempted to come back in. Worked real well for inverse trig. That's bad. U sub, still bad. So what do we do now? Use polynomial division. So we're going to do the following. X squared plus 16 into x squared. This will go once. This will give me x squared plus 16. Subtract it. It'll give me a remainder of negative 16. So now I end up with 1 minus remainder over and we got to integrate this puppy 3 times that. Well, this is pretty easy because what you got now is 3 times the integral of dx minus, and that's going to be 48, 3 times 16 times the integral of dx over x squared plus 16. This is rewalk. This is arctangent. All right? you look, this problem looks just like the first one we had. And I'm not going to go in and work these things out for you. Okay. So that's tale of three integrals, part one. Now we're going to do tale of three integrals, part two. And I'm going to start out looking very similar. Integral of 3 dx. But now this is going to be over square root of 16 minus x squared. There's problem number one. Here's problem number two. And it's going to be 3x dx, the integral. Ooh, yeah. I remember to put my plus c at the end of that one. Well, I didn't finish it up. Don't forget, when you do both of these, combine both your constants of integration into one of them, please. All right. So I've got 3x dx over square root of 16 minus x squared. In the end, third integral is the integral of 3x squared over the square root of 16 minus x squared. Okay, so your first instinct is to say, well, let's look back and take a look at the first ones. So the first one we did, we used inverse tangent. So let's see if we've got arctangent on this one. Haha, no, we don't. So obviously this is going to be something completely new and completely different, and you would be wrong. I'm going to refer you now to page 520, the table of integrals. I shall know these. And if you look around, you'll find this guy right here as the square root of a squared minus u squared, where my a squared is 16, u squared is x squared, which means a is 4, u is x. And if you take a look, this becomes the arcsine of x over 4. And we're, plus c. And we're done. All over, but crying. All right, let's take a look at another one then. Let's take a look at number 2 that I've got. So what I have on number 2 is the integral of, or 3 times the integral of x dx over the square root of 16 minus x squared. You're saying, well, you sub-worked on this before, but I didn't want on this one, and you would be wrong. Because now our u is going to be 16 minus x squared, which means du, it'll be minus 2x dx, and hallelujah, there's my x. So what I'm going to have then, but I've got a negative 2, so it's going to be a negative 3 halves times the integral of u to the negative 1 half du. And this is a Rewall problem. I'm not going to work it. Remember, thou shalt use C. Put your constant integration in. Okay, so that was nice and easy. We did this one. So now let's take a look at this puppy. Okay, what we did before was we just divided the denominator into the numerator. but we have a little problem here with the square root. So what are we going to do here? And here's what I'm going to tell you. If you see a problem like number 3, cry, let yourself, and use numerical integration. That's a nasty little puppy. Okay. So, last thing I want to do then is sort of review and give you another commandment. My basic steps then when I approach a problem. First thing, I always look for a U sub. U sub takes care of a lot of little problems. If that doesn't work, then look for your inverse trig. And these are going to occur, you're going to have something like over 8 squared plus u squared, where u is a function of x. That gives you arctangent. You may end up with something like square root of a squared minus u squared. So this is arctan. It's arcsine. The other thing you're going to see is things like x times the square root of a squared plus minus x squared, which is arcsecant. Okay. So you need to know these. Third thing then, if degree of numerator equals degree of denominator, use polynomial division. And then rule number 4, or step number 4. If stuck, look at list on page 520. Find something that looks like your problem and try it. And then further tricks on next video. Okay. Hint on problems 94 and 98. We have worked similar problems in past. Look in book. I suggest you use the index. or notes. Index is usually a good place to do. So the second algebra commandment of calculus. This is the algebra commandment of calculus. Thou shalt not split up denominators. Don't do it. Thou shalt not. That's a commandment. Okay, so this should get you started on the very first one. And remember, a lot of this is review and taking a look. Big part of what you're going to have to do when you look at these problems is sit back, look at the problem, try use-up, try the different things. Look at the list on page 520. Pretty soon, after you do enough of these, you'll start to get a feel for when you use each one of these particular tricks.